Hello, my name's Trent and welcome to my college mechatronics channel. Today we're going to be going over my lab 4, which is understanding how capacitors work. The materials you're going to need are a breadboard, a 9-volt battery, a power adapter, a power module converting that to 5 volts, 2 momentary switches, 2 LEDs, 2 resistors, 2 capacitors, and jumper wires to complete your circuit. The resistors I'm using are 470 ohm resistors, and the capacitors I'm using are 10 volt 100 microfarad capacitors. The first circuit we have over here on the left with the red button is a capacitor in parallel with a LED, and the one on the right with the blue button is a capacitor in series with the LED. When we turn on the parallel circuit, you'll notice that the light comes on immediately, but when we release it, basically turning it off, it fades out. Whereas in the series, when we turn it on, there's an initial spark and then the light goes out. No, we did not blow that LED. Basically, it's due to the capacitors and how they work. And a capacitor stores energy. So as electricity runs through here, it stores up the energy, and when we release it, it releases that energy back into the LED. Whereas when we do it in series, that energy has nowhere to go. And to understand that, I'll draw it up for you. So the first thing we need to understand is what a capacitor is on the inside. A capacitor is basically has 2 plates and an insulator. The insulator is nothing more than, it can be pretty much anything from ceramic to air to whatever is used as an insulator. Basically, it separates the 2 plates. Before we apply any power or any current through the circuit, the plates start off with an even number of positive and negative, and they are opposite of one another. So you have a negative on this side, positive on this side, positive right here, and negative on the here. When we complete the circuit, what happens is electrons flow to the plate. What happens is they replace the positive charges, or the protons, and as they replace them, because same charges repel one another, it pushes the electron back into the battery by means of using what's called a electromagnetic field. Sorry about the E. So what happens is, as this is being as a current or electricity is being pushed through here, it's creating a electromagnetic field, and that electromagnetic field is pushing across the insulator the electrons. So the electrons, as they replace the protons, are pushing the electrons here back into the battery. And so what you end up with is, at the end of it, as it replaces the protons, you end up with a plate with mostly electrons, and as the electrons are pushed away, you end up with a plate of mostly protons. So for a short while, or basically a split second, you have a connection of electricity, and that is why that light turns on in that series. Once the electrons are placed on this side and the protons are built up on this side, there's no more current or electromagnetic field that's pushing anymore, because we have pushed out all of the electrons on this side and all of the protons on this side. So the electromagnetic field can't push protons or electrons away from it. So now you end up with a open circuit in between here. And that is why your capacitor in series does not work. Whereas In a parallel series, what happens is the buildup happens the same way, but because it is connected in parallel, it has its own circuit to flow through now into the LED. So now, once we turn off the power source, the electrons on this side start to flow through, and the protons start to flow through. Now remember, it can only hold so many electrons and protons in this capacitor. So once the electrons push through and replace the protons, you end up back with basically a neutral charge, what you had at the beginning, or where we started from, and there's no more energy for it to push through because it's the same on either side, so there's no more push. And that is how capacitors work.